Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to determine whether a function is increasing, decreasing, or remaining constant, and how to recognize the maxima and minima of functions. How are we learning it? Through the That Was Extreme notes and the That Was Extreme assignment. When can we use this information? To recognize trends in graphs to determine trends in the stock market, and to recognize high and low points of a given stock in the stock market. How do we know we learned it? By getting a score of 4 on the That Was Extreme assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the That Was Extreme notes, and then I'll give you time to complete the That Was Extreme assignment on Desmos. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the reasoning with features of function study guide and any incomplete assignments that you may have. Let's take a look now at the That Was Extreme notes. The notes begin with the learning goals and success criteria. Now, what are the different types of functions? So functions are said to be increasing when they are moving towards infinity as we work. So they're rising or going up. So during that time, we would say they're increasing. As if the line or the curve is going up on a certain interval, then it is increasing. Decreasing would be the opposite. So as we work from left to right, if the function is going downward, then that is considered to be decreasing. And lastly, if it's not increasing or decreasing, so it's a flat line going horizontally, then we would say that that is constant. So here's some examples. So we have a graph here, and as we look from left to right, it is obviously going upward. So this is an increasing function. This one here, as we go from left to right, is going downward, so this is a decreasing function. This one here is a flat horizontal line, so this is a constant function. Now, not all functions are just one thing. So for instance, we have a parabola here. Well, we can see that on the interval negative infinity all the way until 0, it is decreasing. But then on the interval 0 to infinity, it is increasing. So this is both increasing and decreasing on certain intervals. So we would just need to define those intervals then. So how can we determine the interval then? So the question here is, where is it increasing? Well, we can see that from here, from negative infinity all the way to negative 2, it is an increasing function. So from that, we can state that from negative infinity to negative 2, it is an increasing function. Now likewise, it's going up here as well. So from negative 2 to positive infinity, we are also increasing. So we have two increasing intervals for this function. Now there's a video here that shows you how you can graph functions in Desmos. So go ahead and watch that video now. Let's take a look now at how we can use Desmos to graph any function. So in order to do that, we're going to go to desmos.com and go to Graphing Calculator. And here we can type in an equation. So let's say that we have a linear function, which is y equals 2x minus 5. And notice it graphs it for us. It creates this graph here. We can type in any kind of function. We can do an exponential. Y equals 2 to the x power minus 5. That's what it would look like there. We can type in a quadratic. Y equals 2x squared minus 5. And see exactly what that one looks like. We can do trig functions. So y equals sine of 2x. And that's what it would look like. We could do logs. Y equals log 2x. And see exactly what it looks like. So we can graph any one of these kinds of functions and it will do it for us in Desmos. If there's ever any difficulties with what you're trying to do, so let's say I'm trying to do a squared term, so y equals x squared, and you're not sure how to do that, this little keypad here will click out, and now I can change it to be squared. I can change it to be any exponent here, so I can click on this and make it to the 6th power or whatever I want it to be. So you can use this any way you want. And this is how we can use Desmos to graph any function. Now, what are minima and maxima? Well, a maximum is the largest y value that corresponds to an x value in a function. So what that means is, as I look at the graph, where is the highest point that it's reaching? And if it never stops increasing, then we would call that infinity. But if it goes up and then bounces and comes down, then whatever that highest point is, that's our maximum. The minimum is the exact opposite, so it's the lowest value. So if it goes down forever, then we would say our minimum is negative infinity. But if it bounces and comes back up, we would call that our smallest value, whatever that point is. Now, a maxima is a plural form. So we could have a function that goes up, goes down, goes up, goes down multiple times. And each time it goes up, that is considered a maxima. Now, it may not be the ultimate maximum, but it is a maximum. So that represents that value. The minima is the same thing, but just the low points. So for instance, we have a parabola here. Well, we can see that it has a minimum right there. It does not have a maximum because it goes up forever. So it has a minimum here, but not a maximum. Now this one goes up and then comes down. So it has a maximum, it stops there, and the minimum just goes to negative infinity. So it only has a maximum here. Now, what is a relative minimum and maximum? So, like I said earlier, we have these different minima and maxima. So on this question, it asks, where is the relative maximum and what is the relative maximum? So the location is written as x equals a. So we just need to write out the x value. Well, this is a minimum here, right? And then it goes on forever. So this is not considered a relative maximum. This is an infinite maximum. So my relative maximum is right here at this point. So I'm just going to write down the x value. That's all I need to put. Now the maximum value is the y value when x equals that. So this becomes the y value. So right here's my point. So my location would be the x coordinate, which is -1. So I would say x equals -1. Now my actual maximum is the y value at that point, which is 1. So I would say y equals 1 is my maximum. Now if we look at this for the minimum now, again, we write the location as x equals a and the minimum as the y value when x equals that coordinate. So here we have a relative minimum right here, and we know that the location, the x coordinate is -2, so x equals -2 is the location, and then my actual minimum will be the y value at that point, which is 3, so I would say y equals 3 is my minimum.
Let's talk now about how to sign in to Desmos to complete your work. So what we're going to do is you're going to click on the link to go to the assignment, and it should take you to a page that looks kind of like this. And right here where it says sign in with Google, we're going to click there. And it's going to pop up with our email accounts. You're going to click on your school email account, and it should already have you logged in because you should have already been logged in using Google Classroom. From there, I'm just going to click start the activity, and it will take me into the assignment and allow me to begin. So that's how you will log into Desmos using Google.
Let's take a look now at the That Was Extreme assignment. The assignment begins with the learning goals and success criteria. If we scroll down, there's a link here to take you to the Desmos activity. Go ahead and click on that link, and it should take you to a page that looks like this. We'll go ahead and click Start the Activity. The assignment begins with the learning goals and success criteria. We'll go ahead and click Next. Now there's a video here for you to watch. It says, life is hard, sometimes things get really extreme. Just like Mulan, never stop fighting. Even in the most extreme circumstances, keep pushing on because you can and will succeed. So go ahead and watch that video now.
The girl who has come to save the dynasty. rise up. You are a mighty warrior. Rise up like a phoenix. Fight for the kingdom and its people.
And then we'll go ahead and click Next. Now we're going to decide where the graphs are positive, negative, increasing, and decreasing. So where is this graph positive? Well, it's positive from 1 to 2. So we'll go ahead and put this on the interval from 1 to 2. It's positive. And where is it increasing? Well, it's increasing from negative infinity all the way to 2. So we'll go ahead and put that from negative infinity to positive 2. It is increasing, because notice it's going up the entire time. Now this one, where is it positive? Well, it's positive from negative infinity all the way to 2. So we'll go ahead and put that in. From negative infinity to 2. Now where is it decreasing? Well, it's decreasing the entire time. So it's decreasing from negative infinity to positive infinity. So you'll answer these questions for each of them. Now, some of them will ask, where is it constant? Where is it negative and increasing, decreasing? And then we'll go ahead and click Next. Same thing, where is it positive? Where is it negative? Where is it increasing, decreasing? Where is it staying constant? So you'll answer it for each of these. Now, when it comes to the relative maximum and minimum, notice it gives you the x value and y value. It wants you to give both. So where is a relative maximum? Well, right here is a relative maximum, which is at negative 1, 1. So the x value is at x equals negative 1, and my y value is at y equals 1. And we're just using the coordinate for that. Same thing with the minimum. So we have a minimum here, and my minimum is at x equals negative 2, and y equals 3. So we'll go ahead and hit Submit, and then go ahead and click Next. And we'll do the same thing for this one. And we'll keep doing that. Now here we're going to look at Sue, who's looking at the graph, and says that negative 1, negative 3 is a relative minimum. So negative 1, negative 3 is a relative minimum, which we can tell is correct. Tom agrees with her and explains it as a minimum point because E is at negative 1 and point M is at 3, and negative 1 is smaller than 3. Taylor disagrees with them and explains that point M is at negative 5, which is smaller than point E, which is at negative 3. Sandy can't decide because the point M is below point E, and that would make M a minimum. But E is to the left of M, in which case E would be a minimum. So your first statement is this true? Well, we could see that point E here is a relative minimum. It's not the minimum, but it is a relative minimum. And you're going to state why. Then you're going to critique the reasoning behind each of the other three students. So Tom says that because point E is at -1 and point M is at 3, then -1 is smaller than 3. So is he right? We would say that Tom is not right because he's looking at the X values instead of the Y values for the minimum and maximum. And then you'll do the same thing for Sandy and for Taylor. So you'll answer each of those, and we'll click Next. Now we're going to sketch a graph. It says each of the following describes a function with certain characteristics. So we want to draw a function that has 2 relative maximums and 1 relative minimum. So that means it's going to have to go up and then back down, and then up and back down. So we have a relative maximum here and here, a relative minimum, and then it goes on forever this way. So that would be an example. We'll do the same thing here. This time we're looking at 2 relative minimums and no relative maximum. So in this case, we need a minimum, so something like this. So then we notice that it gets really close to the asymptote, but it doesn't actually cross it. So then we can start over again on the other side, just like this. Now we have a minimum, but no maximums. Now at the end, there's a video here from Cars. It says, "You made it through the extreme times and succeeded just as we knew you would. Just like Lightning McQueen, you made it look easy. Just remember to always stay humble in the process." So go ahead and watch that video.
Got it goes all mine. Get through that, McQueen. A huge crash behind the leader.
Wait a second, Darryl. McQueen is in the wreckage.
There's no way the rookie can make it through. Not in one piece, that is.
And then when you're done with that activity, you'll go ahead and go back to your Google form and click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go and then submit your work on Google Classroom.